Well, good afternoon. I'm Chris Scherer, Member Communications Director of the Society of Broadcast Engineers and the co-host of this month's episode of the SBE WEBxtra, the SBE chapter of the web. This is a monthly SBE meeting, usually held on the third Monday of the month. The SBE is the Association for Broadcast and Multimedia Technology Professionals with about 5,000 members, mostly in the U.S., but also around the world. The SBE WEBxtra is sponsored by Katrine. Katrine, unique experience, individual solutions, reliable performance. The host of today's SBE WEBxtra is SBE board member Kirk Harnack, who is also the chair of the SBE Social Networking Committee. How you doing, Kirk?
Hey, I'm good, and hello, Chris. Good to see you. I'm excited about this show. By the way, I should mention that I walked into one of my radio stations a couple weeks ago, and there's a big box from Katrine right there. We bought another 950 megahertz antenna. And it was actually it was one of the mini flectors, but it comes fully assembled, so the box is big. So, good to have that. So our guest today, our guest is a person who's been in the news lately actually been in the news for the last several years. He writes articles as a way of getting out what is in his head, in his heart, in his mind, his experience out to engineering professionals. Lately on the topic of SMPTE 2110, SMPTE, the Society of Motion Picture and Television Engineers, and 2110 being the body of standards, so the group of standards that has to do with television and audio over IP. So we're going to be talking to John Mailhot about this. John Mailhot is his name. By the way, we'll bring John on in a minute after our announcements, but John's got this great slogan. He describes himself as 32 years, 7 companies, 1 desk. I think that's so cool. We'll find out more about what that means from John Mailhot in just a few minutes. Chris, you have some member announcements for us.
Yeah, that sounds like the opening of a movie trailer, and I'm sure he'll tell us more about that as well.
But in a world.
So here is your SBE member update for March 15, 2021. The SBE launched a new series in the Webinars by SBE. It's the 2021 IP Networking Series. The first 2 parts are available on demand. Part 3, a focus on everything Layer 3, airs on March 25th. Wayne Pacina leads these webinars. Later this week, on March 18, we present cybersecurity for remote transmitter sites. Peter Burke, president of Burke Technology, will explain how remote transmitter sites can be integrated with studio, NOCs, and field access while keeping the IT department happy. Cybersecurity breaches, specific vulnerabilities to Internet of Things devices, the special challenges of Knox, and much more are all on the agenda. For information on these and all the webinars by SBE, go to sbe.org/webinars. The SBE is planning the next Leadership Development course, which will be held in Atlanta on June 8th through 10th. With a foundation going back to 1965, the SBE has presented the SBE Leadership Development course since 1997. This course is designed specifically for broadcast engineers who have or aspire to have management responsibilities. The SBE offers the course in cooperation with instructor Rodney Vanderveer, a professional leadership and management trainer and a professor of organizational leadership and supervision at Purdue University. You can register with our no-risk guarantee. If the course must be postponed or canceled, your registration fee will be refunded. Make your reservation and get more information at sbe.org/LDC. The next SBE certification exam window at local chapters is June 4 to 14th. Applications to take an exam in June are also due to the SBE National Office by April 16th. And remember, if a local chapter exam is not convenient for you or not possible because of COVID restrictions, private proctoring is available. The new SBE Specialist Certification, ATSC3, is now available. There are a few people who have already added the ATSC3 Specialist letters to their professional titles. And more information on SBE certification is online at sbe.org/certification. The annual SBE membership drive started March 1st. It runs through May 31st. The theme this year is Add Power to Your Profession. Sponsor a new member to join the SBE, and you as a member can benefit as well. You'll be entered into a prize drawing for each new recruit, including a chance to win a trip to the SBE National Meeting, and you can earn a savings on your 2022 SBE dues. Recruit someone today. Get all the details at sbe.org/drive. And don't forget to renew your own SBE membership. It's officially due by April 1. You can renew online at sbe.org/renew or follow the link button on the homepage. The annual SBE Awards program recognizes those who have contributed to the SBE, the industry, or their chapters in a number of categories. Winners will be recognized at the National Awards program at the annual SBE National Meeting. Honor your colleagues and chapters by submitting an SBE Award nomination. They are due to the national office by June 15th. And one more, chapters make note, if you're meeting virtually, you should still report those meetings to the national office just as you would an in-person meeting. These meetings count towards the minimum 5 meetings held during a calendar year necessary to qualify for an annual chapter rebate. If you hold your meetings via Zoom, there's a way for the meeting host to export all the attendee information, which simplifies the chapter secretary's task. Chapter leaders, there's a link to the instructions on the SBE website under Chapter Administration. Go to sbe.org/chapter-admin. And that is your SBE member update for March 15th, 2021. Kirk?
That's one of your longer updates, Chris. A lot going on, isn't there?
That was a bit of a long one. Yes, that was all in one breath. And one take.
One take. That's good. Excellent. Okay. Thanks for the links, too. We'll have those links in the show notes as well. All right. Our guest today, John Mailhot. John, the man who says he has 32 years, 7 companies, and 1 desk. And I got to know exactly what he means by that. John is the CTO and Director of Project Management over at Imagine Communications, but he's held a number of titles in the last 32 years with 7 companies and 1 desk. John, welcome in. Good to see you on SBE's Webxtra.
Thank you, Kirk. Thanks for the invite. Always a pleasure to talk to people, even if it's virtual. It was about a year ago today was my last in-person meeting with the customer, and also about 2 weeks before that was my last haircut. So during the beard lifestyle here, I'd never really tried this before. Yeah, it's 32 years is a long time, and that's the amount of my career I've been working in kind of the television part of things. But like all companies these days, Imagine traces its roots to a lot of predecessor companies. So Imagine is what was once Harris Broadcast, which was for some people Leach, for some people Encoda, for some people Louth, for some people other companies. I came into it through a path that goes all the way back to Lucent Digital Video, makers of the Flexacoder, for people who go back that far.
John, the Emmy Awards have been on folks' minds here, and I was looking back at your history. You accepted an Emmy Award on behalf of, was it Harris? Having to do with Jpeg 2000, an engineering Emmy Award.
Yep, I've had the pleasure of standing on the stage twice, actually. So I was part of the engineering team of the Grand Alliance. So everybody remembers the Grand Alliance was AT&T, Zenith, MIT, General Instrument, Thomson, Phillips, Sarnoff. If that's 7, great. If not, I messed something out. I'm terribly sorry. And the reality of the Grand Alliance was it was a bunch of companies all working together. So I was involved in the AT&T part of all that. And so that was my first trip to the stage, accept an award on behalf of the AT&T on behalf of the Grand Alliance. Then later we worked on Jpeg 2000 interoperability standards, which was an interesting precursor to all this, because it was another case where people took an idea, let's use Jpeg 2000 for video, and then went off and did it a couple different ways, and no 2 things worked together. So then there was an industry effort to, let's write it down, let's do it a specific way, let's have interop tests, and that Emmy was a recognition of that work. And that work was actually done in the Video Services Forum, which is a great organization that I have the pleasure of serving on the board of.
John, I don't think I can take credit for it, but one of my favorite phrases is, this is the beauty of standards. There are so many of them.
That is a common joke, and it is not untrue. There's both too many and not enough.
Well, that's interesting. I was watching a video recently on the charging connector standards for electric vehicles, and of course there are at least 3 and maybe 5 and maybe 6 and maybe 7 different ones. And you can't drive your car to other countries and expect to plug it in at all.
Can you even drive your car around this country and expect to plug it in everywhere?
That may be a problem too. So we're here to talk about SMPTE 2110 and that family. And I don't think we're going to spend much time on describing what SMPTE 2110 is. Maybe we get a couple of sentences like whatever the Wikipedia entry is for the first paragraph. You can tell us about that. But then I've been hearing this standard SMPTE 2110 for quite a while, and I work for a company, the Telos Alliance, that builds audio gear that does work in a SMPTE 2110 environment, supposedly within the 2110-30 part of these standards. But at the same time that I keep hearing about 2110, I also keep hearing people about, we're doing NDI, or we're doing CDI, something I think from Google, and so I'm a little confused. And then other people saying, we've just decided to stick with SDI, or we're doing a hybrid, a little bit of 2110 where it makes sense. So I'd like to get a kind of an understanding, what's 2110, and then spend most of our time talking about the practical implications of television stations or others, video production companies, and so forth, implementing this. What are they finding? What's available? What difficulties are they coming across? And what difficulties? Well, this was a difficulty, and guess what? Now that's solved. People got together and solved that problem. So why don't you begin us a little bit with what is 2110? Just a paragraph or so.
Sure. No, 2110 is exactly what it says on the tin. 2110 is doing audio, video related ancillary data over IP networks. And in practice, what does that mean for people? That means that you can buy commercial but good Ethernet switches or IP routers, however you think of them, and you can hook SMPTE 2110 devices to them, and you can connect them up and make a working system where traditionally you would have put an SDI router. Now, that's a beautiful, high level, sounds great, can I have three? And the truth of the matter is, it is not a trivial system, but it's reasonable. And there's been a lot of technical work over the years now. The committee process started probably in 2015, maybe even before that. The SMPTE work, the SMPTE standards, the original versions were published in 2017. Here we are in 2020. So we've had a while as an industry to get used to the idea we're going to do this all on IP networks. And we've had a while for all the equipment vendors to get it into products. And you mentioned Telos Alliance has products that do it. That's great. Funny enough, Imagine does too. Our folks a little more on video processing. Historically, our leech roots come through. But you'll find almost any video audio processing kind of product that you'd want to use probably has an ordering option now to do SMPTE 2110. So we've been for several years now going through this maturity curve of, first it was an idea, then it was a prototype, then it was a first gen product. Most people are on their kind of second gen 2110 products that are in that zone where they plug together and they work. And we're really glad as an industry to have gotten there. But it's been the work of a lot of hands to get it there. So the 2110 started in the Video Services Forum. The standardization was done through SMPTE. There were interoperation events where everyone got together and plugged their things together. Those were hosted out of the Fox Woodlands facility several times, and now it's the Disney Woodlands facility. Same gracious people, just different name on the front of the building. Then equally the EBU, the European Broadcast Union, did a ton of work on defining a test plan, a test program that became what's called the JTNM tested program, where vendors, big and small, could turn up at events and go through a whole bunch of testing. And we were just about to do another one of those last March when the whole world came to a pause, and so did that event. But I'm sure we'll do one of those again in the near future. All to say, from a standards perspective of, is this written down? Is it written down well enough for people to build equipment that can hook together and work? From that perspective, 2110 has come a long way. It's well enough written down. I think people understand it well enough to build equipment. And as we build projects on behalf of customers, the expectation is now that things will plug together and work. And we deal with exceptions when they don't, but most things now plug together and work okay. Now it's down to the who and why.
Yeah. Yeah, I got to participate with my friends at Yamaha a few years ago, right before an AES meeting on the West Coast. And we got together and hooked up a bunch of different brands of AES 67 gear. And so this is kind of my exposure into the world of standards like this. And it took a day to get everybody talking to each other. And they were all designed to talk to each other. They were all AES 67 compliant. But, one company, we need a semicolon at the end of this line. Another company didn't need a semicolon at the end of this line, right? And so there were just little tiny differences in implementation that made us pull our hair out for a couple hours until we got it figured out. And when I heard of companies wanting to build a SMPTE 2110 facility running across, I don't know if this problems were that simple or if there really were bigger problems to solve, but you mentioned plug fests. And I think that this has been a terrific thing, at least in my exposure with Telos Alliance. Back in the day, we had ISDN plug fests, and then we had AES EBU, AES3 plug fests, and then we had IP codec plug fests. And it's amazing how this is, these really do help. Has that been a real boon to getting 2110 going amongst manufacturers?
Oh, for sure. I mean, it's I think it's a different time and era of the industry now than it was like 20, 30 years ago, right? When SDI came out, there was, vendors hardly knew each other, right? I mean, you could say, I got this from Sony, I got this from Panasonic. If they didn't plug together and work, it was really hard as a customer to figure out, how do I get them to talk to each other? As now, these plug fests that have happened, as I mentioned, a bunch of them happened in the Woodlands, Texas. One or two of them happened in Europe as well. They've been super helpful at several levels. They're helpful during the event because the vendors all, you're all there in the room, and you get the engineers in the room where they're just arguing about whether the spec says this or that and who's, which product did it right, but everyone's goal is sort of aligned at getting it working. And so it's when you get the engineers in the room separated from the people who are more worried about blame and money, things can progress really nicely. And it's a nice neutral environment. You're not there at a customer install where the customer just wants it on the air and everyone's shouting at each other. You're there in a room where we're all having a conversation about the same thing, and afterward we're going to go drink beer together. So it's a very different environment to debug in. But secondarily, the lasting value is that it's caused the engineers at probably all the vendors in the industry that are involved to know each other as people, because every night we'd all go out and eat dinner together, and then we'd go out and talk about movies and all that. And basically, it caused a bonding of people across all the vendors to where now, if we're at a customer project we're trying to build out and we have some complicated question about a piece of equipment, I can call up somebody in engineering at that other vendor and say, hey, remind me again about this thing, and they'll say, oh yeah, you have to do that. It's caused a knowledge of who we are each as people between and across all the vendors that's really unique. I mean, during the rollout of the ATSC standard many years ago, it wasn't that way. It was very hard to find, an engineer to talk to at television manufacturer X if you were making the broadcast side of the equation. It was just, different people, different time, a different era. But now this ability to know each other as people across the engineering ranks of the equipment industry has become invaluable.
Thinking about some standards that we have implemented over the years, some are regulatory, right? ATSC 1 and eventually ATSC 3. There's no legal reason to have to go to ST 2110. What are some of the triggers that would prompt a TV station, a content creator, other production facility to say, you know what, we're going to rebuild this, or we're going to at least do a couple of rooms, or we're going to redo master control? What are some of the triggers that make people think we really ought to think about not doing this with SDI anymore. We need to think about doing this with SMPTE 2110.
Oh, no, that's the important question, right? Because if you think about SDI, we're in the golden age of SDI. And you can buy an SDI router from one of 6 or 7 vendors, including us. They work fine. They're at their peak of development. I mean, they have the best cable equalization they ever had. They have audio muxing and demuxing and MADI and every other feature you could want built into the router. What's not to like? So like any technology transition in television, and as an industry, we've been through a lot of these. It's not an overnight thing that everyone just suddenly is doing this new thing. It's always driven by a need. What production feature or what special thing can I do in this new technology that the old one didn't let me do? So the early implementations of SMPTE 2110 were pretty much all driven by either scale or scale in a different way, which is to say, SDI is great until you go above about 1,000 inputs on a router. Once you kind of cross that 1,000 or 1,100, whatever inputs on a router, suddenly the scaling pattern of that router gets really hard. Suddenly you're not just, I got to add a few more cards. It's, well, when I go above 1,000 inputs, I have to break it into 2 frames, and then that makes 2 more frames behind for all the crossover, and suddenly it turns into a much, much bigger system. So there's like a breakpoint there, and people have shouting, screaming arguments over router ports because of that size limit, that above it, things got super hard. So pretty much the early adopters of 2110 were people who needed to scale to something that had either more than 1,000 inputs, 1,000 video inputs, or more than 1,000, or really more than 2,000 or so outputs. Because you can always make more frames to have more outputs, but you get into a certain system size, SDI starts being really hard. The squaring of the system makes it giant. So there was that. Equally, UHD. So as people started to want to produce a non-trivial bit of UHD, 3 gig SDI, well, it takes, it's a 4-wire signal in UHD to route around. So that suddenly what was a 1024 router becomes a 256 router. Oh, that's not a giant router. 256, that's like a bread and butter router. So it really, those scale factors of being able to go to bigger than a certain size, and by the way, UHD made that size smaller, that drove a lot of the early adopters, the UHD projects, and even the big trucks that were being built that had to be able to do UHD. And by the way, when they weren't doing UHD, they had to support a lot more cameras and things. If you look at a lot of the early truck projects that went to IP systems, they were driven by scale and UHD. But it takes years to roll to a new technology. So those early adopters are driven by that. Where we see it now is, again, big projects. Like, if you have a playout center that's making 30 or 40 networks that are going to air, and you start looking at the main and protect versions of those, and then the ACOs, and then what comes after them, and then all the multi-viewers that you have to feed for the people who are going to curate that content, and then you got the ingest side of those. You can get out of 1,000 by 1,000 router really fast. And so for big playout center, IP starts to tip the scale pretty hard. But if you're talking about a second 20 market, market 20 to 50, and you're just rebuilding like the newsroom because everything else is sort of central casted out of somewhere else, suddenly you're saying, well, I'm not probably going to do UHD. I'm not even at 1,000 by 1,000, right? I mean, a 288 by 512 router might do great. The economic driver of staying in that SDI router might be really good, right? So unless you're updating like everything else in the plant, don't think of 2110 as just, oh, I got to replace my router. 2110 will only make sense in a medium-sized environment if you're also updating some major subsystem, updating the switcher, updating graphics, updating something else. If you say it's just, my watch says it's time to update the router because it's been 8 years or whatever, don't approach it as a 2110 project necessarily. I mean, I never want to discourage anybody, but you won't see a benefit if you use it exactly like SDI in a hole that SDI would have filled.
So I take it that for the major components like the router and video, vision switchers, things like that, if you're going to go to 2110, those things are going to be 2110. What about the things feeding in? Is it reasonable, easy, convenient to buy little converter boxes that convert, so incoming out and edge devices into 2110 compatible by putting a converter box there?
Yep, there's a marketplace full of those boxes, and they're everybody from AJA to Ross makes one, we make one, other people make them. They have different features too. Some of them are just simple converters. Some of them have all kinds of color processing. Ours is like a frame sync. I mean, it's like your old Leach X75, Leach X85, but now it's got 32 of them in there and a million knobs and HDR and all kinds of other stuff. So it's the nice thing about the marketplace of all of us is that it gives you choices. So if you just need a simple, turn SDI into IP gateway, those exist. If you need a video processor, those exist. If you need a vision mixer, the usual suspects all make those with 2110 now. Like I said before, just about every product you could want to buy, there's probably a 2110 version of it from the usual suspects. And if there's not, there will be next year.
So excuse my ignorance on this topic, because I come from the audio world, and when we went to audio over IP, an off-the-shelf, properly configured switch, typically from Cisco, became our router, right? We could, it was all multicast, and we could easily tell an edge device, hey, switch from this subscription of multicast over to this subscription of multicast, and bam, you've got a switch right there. We don't have frame sync to worry about. The switch happened quickly. You never noticed a blip in the audio, just that a different source was now coming out of the output. So how is this different in the world of video? How is vision switching in the IP world done in such a way, and where is it done in such a way that we're not, like hard switching, like like in the old days when we took a mechanical switch and switched from one feed to another, and we got half a frame of flip on the TV sets. How is this done smoothly in the IP world?
Well, you had a good experience in AES-67 in part because the end devices did something good for you. So most end devices, they actually did do start taking the new stream, do a little duck and over or something to it. If they really did a hard cut, you would have heard a pop once in a while. Mm-hmm. And since audio engineers hate those pops, most audio vendors made a little duck or something so that the audio transition was good. In the video industry, very much the same thing. If you want a nice clean transition from one signal to the next, most devices that do that will join the new one, they'll synchronize it to frame, or they'll synchronize it to the other one, and then they'll do a nice proper RP168 or better, cutover to it, so that things downstream perceive it as a nice continuous video signal. And any device that's in your air chain, or that's potentially hot punched into your air chain because of whatever horrible set of reasons might have happened, you should make sure that it's able to do that, nice, clean, quiet switch from one signal to another. And yet, also in the marketplace, there's devices that sometimes cost less or maybe have fewer features that don't do that. And they're suitable for other parts of your system where they're not, quote unquote, in the air chain. And so you get to do the best of all worlds. You can economize for some equipment that's not in the air chain and use maybe, lower end, or maybe devices that don't do a nice clean switchover. And then for things that are in your air chain or in your backup air chain, you can use things that do a nice clean switchover in case you wind up doing a hot punch to air for some reason. And ultimately, it all goes into master control. And if it's on preview when it switches, doesn't matter, because what matters is the program bus.
Yeah. Yeah. Wow. Okay. I'm getting such a good experience here in understanding some things about 2110 and IP video. We're talking about it with John Mailhot. John is the CTO and Director of Project Management over at Imagine Communications. He likes to say that he's got 32 years, had 7 companies and 1 desk, putting all these things together into a career of helping the industry in coming up with standards, and then helping broadcasters and other video producers to implement those standards. We're talking about SMPTE 2010 in this context here. John, I want to touch a little bit more on these IP switches. In the early days of IP audio over IP, there were just a few switches that actually did the job correctly. They actually handled multicast audio and the IGMP and so forth, to handle it correctly, that we could recommend, that my employer could recommend. Now, more and more switches do that. More and more just come with this capability. What's this like in the world of video? What kind of Ethernet switches are good for SMPTE 2110?
So in the 2110 projects, there's two sets of requirements for the switches. One is that they support the PTP timing. Mm-hmm. And there's a lot of switch vendors that do, and that's great. It's become, it's gone from 0 of them so many years ago to now all the major switch vendors have at least models that support PTP timing. They don't necessarily support PTP in every model across their whole line, so you have to pick models that do. And then the second factor in these video projects really is the bandwidth, how many ports at what speeds to mop up all the signals you have. And that's where that's where a lot of the smaller switch vendors tend to fall out, is whether they have models that go to 11, that go to really big. Mm-hmm. The main players in projects worldwide tend to be Cisco and Arista. They both are, competitors to the death on big data centers, on financial trading institutions, on the big banks. It's great for once that television is not the highest spec driver of a technology. It always felt like in television, we were the people who wanted to get the most bandwidth over a wire, or have the fanciest connectors, or have whatever other technology we used it the hardest way. But in these Ethernet switches of this scale, Google, Amazon, Facebook, all these big data centers, they're using bigger models at higher line speeds than you need in a big TV station. So for once, we're not driving the bus on the technology. We're riding about 3 rows back, watching other people take the spears. It's a good place to be from a technology standpoint. We're able to leverage the optics advances and so forth without having to drive them economically. So the big switch vendors tend to be Cisco, Arista, Mellanox, who's now part of NVIDIA, is probably the third player there. And then in Asia Pac, Huawei is a big vendor. You don't see them so much in the US, but big player in Europe, or in parts of Europe and in Asia Pac. That tends to be the class of switches you see in these big TV environments. Within Cisco, because they have 1 million product lines, it tends to be the Nexus 9000 line that has the right number of ports and speeds and PTP awareness. Within Arista, it tends to be the 7500 or 7800 series, depending on the size of the project. But they both, perfectly capable models. The Mellanox, they have their own set of models that also do it within the size ranges they support. So there's plenty of switches to choose from, and it's good to have choices, because ultimately, like anything, if you have 2 vendors who both make one, then as a customer, you have a position of choosing. The same thing with the core network. If you have two vendors who make it, Cisco and Arista and NVIDIA and whoever, then you have more choices of speeds and models and, frankly, dealers, distributors, and overall, pricing combinations. So it's good to have choices. And the whole point of having these standards is that there's a marketplace of products for the switches, for the optics, for everything that you can choose from to build the system you need.
Let's talk for a minute about how a TV station engineer or a facility engineer, other director of engineering, they feel like, we're going to need to be moving into this technology. Should I be talking to one vendor like you at Imagine? But there's always a little fear that if I talk to one vendor, I may, because I don't know everything about all this, I may end up unwittingly getting myself locked into one vendor. And of course, standards should make things somewhat interoperable. And you don't want to necessarily be in the position of being locked in, although you do want the support and the financial wherewithal, the stability that a large vendor would bring. Talk to me about that technical and business relationship, about getting involved with 2110, and then how you go about managing that from a technical business perspective as the customer.
Sure. I mean, there's a couple ways that people go about managing it. One is most vendors don't make everything, right? So if you talk to us, great, we make a bunch of stuff, but we don't make cameras, we don't make switchers, we don't make EBS replay machines, so forth. So our nature is we have to interoperate with everybody else, because the only way that you as a customer could build a system is for us to interoperate with everybody else. And the same is true of most other vendors in the space. There's very few vendors that make everything. I mean, if Grass buys many more companies, maybe they'll be one of them. But it's on the whole, the nature of the equipment industry is such that we have to interoperate with each other. Now, as the second part of the equation is that most projects involve somebody doing some heavy lifting for hire, a system integrator or somebody like that that's going to look after organizing all the parts, maybe doing some of the engineering of the project. It's just the state of it is that the projects do take some engineering time and effort that may or may not be doable by the current staff who's also trying to keep the current system on the air. So most projects seem to involve, at least so far, a integration company, a Diversified or Beck or Alpha or CTG, or one of many integration partners. And they tend to have relationships with a lot of vendors because, again, every project involves more than a few vendors. So definitely, you need to expect that the project's going to involve multiple vendors. And if a vendor comes to you and says, we'll do this whole project, but we can only do it if every stick of it's from us, then they've pretty much just laid their whole hand on the table in front of you. And that should be a warning sign.
So, and I know I keep relating this to my own experience in audio over IP, but a lot of radio stations went through this transition over the past 15, 16 years or so. And one of the things that I would tell an engineer is that you're doing audio over IP right if at the end of the project you have literally a dumpster full of wire that you've ripped out and put out in the dumpster, and you're going to use an amazingly relatively small amount, or comparatively small amount, of Cat6 cable. Is this we even figured out one time, all that wire we pulled out of that facility in New York, that probably weighed about 4,500 pounds. There's that much less wire in the building is supporting that much less cabling now. Is there any kind of cabling advantage with SMPTE 2110 if a facility converts and gets rid of their older stuff and does all networked video audio?
It absolutely. It's a huge cable savings. I mean, we did a nice big project through Diversified for QVC Japan. And QVC Japan, you say, well, it's QVC, but it's a 6 stages, 24 cameras, 2 control rooms, live 365 days of the year, serious production, right? And
Yeah.
all in UHD and HDR. And so you walk behind the racks, and the first thing that strikes you is, where's all the wire? Because suddenly you have like a CCU, right? Typical camera control unit. Normally there'd be like, for UHD, you'd have, the UHD SDI cables, the HD SDI cables taking the down convert and so forth, plus the tally monitors back going in there, plus the audio from the camera, because there is audio from the camera. Even if you don't use it, it's still there, and people still wire it out just in case they use it. And, all this other stuff. And suddenly, what do I have going in the back of the CCU? Oh, there's a pair of fibers, main and protect, and power. and yeah, there is a control Ethernet over there. And then the only spaghetti left is actually the tally lamps, because those aren't quite IPized yet. It really is shocking. I mean, you walk behind the rack and you're like, where's the rest of the wiring? But early on in this transition to IP, we started talking to our system integration partners, the Diversifieds and Bex and all these people. And we said, well, how much does it cost to run a cable? And they said, well, we don't price it that way, blah, blah, blah. But eventually they came out with it's about $50 a wire. By the time you project manage it, and it has a label on both ends, and somebody strung it, and you divide out the whole project. And we said, well, if those were Ethernet cables instead, would they be any cheaper? And said, no, it's still about $50 a wire. But this point of simplification is suddenly there's just a lot less wires. I mean, SDI is 1 wire per signal, and 100 gigabit Ethernet is more like 50-ish video signals each way on that 1 wire. They all go back to the switch, so there's not nearly as much puzzling over, well, this one goes exactly here. They all go back to the switch. And yeah, the simplification and the simplification of the volume of cabling is huge. And we've seen this also in refits be a big deal, because when you're in an existing space, like we did a refit of a video control room in a stadium that was, the stadium existed, the conduits were already run, we had to build this overbuilt of the existing system before they took the old system out. Suddenly the fact that, it's just this little bundle of fibers made a huge difference, made a world of difference, because that was the only thing you were going to be able to get in that conduit. And frankly, we ran it next to the conduit because the conduits were full. So yeah, that simplification is huge, especially because now think about all the stuff that's going over that same Ethernet cable. It's not just video, it's the video and the audio. Okay, we always had those. Oh, and the black burst, or tri-level, depending on what you needed, or both, because you ran both because you didn't know which one you were going to need, and LTC times redundancy. So suddenly you've saved a ton of project effort by just having a lot less cabling. And I think that's one of the things to keep in mind when you look at your 2110 equipment, is you say, well, this piece of equipment's a little more expensive. This piece of equipment, and that Ethernet switch isn't free, but maybe it doesn't cost what the SDI router used to cost, but it's still not modestly expensive piece of gear. But you have to look at the total cost of the project and the total cost of owning the stuff going forward. Power budget's just another thing, right? I mean, compared to the transmitter, everything else is low power. But you look at a facility and you start counting kilowatts, and you say, well, how many kilowatts did the SDI router consume? And it's a non-trivial power budget. You say, okay, well, the Ethernet switch that replaced it, it's maybe a 2RU switch or something. A lot less power budget there. And you can look at that whole cost and say, there's some economies that don't come from the box, but come from the system when it's finally done.
I've heard a story a bit similar to this myself. About 12 years ago, I was interviewing a fellow who at the time was the audio engineer for the New York Metropolitan Opera. And he had to run some new audio cables to some spots, and he ended up going with an audio over IP system that I consulted with him on. He said, we're out of room in the conduits. Okay, well, I can pull one cable and one Ethernet cable did everything he needed to do. He had multiple feeds in each direction. And this was 12 years ago. This was like a new hot thing. This was just amazing. He said, I could not have done this. And by the way, he said, I did it myself. I didn't have to hire the usual New York City required labor to do that. I could pull that myself. So we're talking to John Mailhot with Imagine Communications. He's the CTO and the director of project management there. Sorry. John, I wonder if we might pivot a bit into control, because I keep hearing about things like NMOS, and then I hear about other alphabet soup control protocols. Talk to me about control protocols in SMPTE 2110.
Sure.
Right.
No, control is the other half of the problem. So in SDI, it's easy because all the routing's done in the router, right? So
yeah,
the signals coming into the router always come in. Signals that come out, the router did the switching. Everything just eats what they get. IP is a little different because the endpoints are part of the router. The endpoints, like the monitor, say, you have to tell the monitor which stream to ask the network for. So there's a control protocol for that. Now, in the early rollout of 2110, we were in this business of writing drivers because we make a control system. So we had to write a driver for every different piece of gear. So we get a driver for the Tech Prism, we get a driver for this, a driver for that, a driver for the KX spring, and you name it. We hate writing drivers. Writing drivers is a terrible business for us because it's too many of them and everybody wants a different one. And by the way, customers hate paying for drivers. I've noticed this over the years. And, I don't like writing drivers because it's just inherently a crazy business. NMOS is at its best. NMOS is like a universal driver. So when a device speaks NMOS, then we don't need to write a driver for it because we can use NMOS to tell it what streams to take. We can use NMOS to tell what streams it's offering into the network. And that is a game changer for the industry, that we have now a common control protocol. We got away without this for years, right? The SDI equipment didn't have any common drivers. We make automation systems. We had to write drivers for every different video server. We had to write drivers for every different production switcher. And we still use those drivers to control, is the switcher transitioning? Is the playout head playing? I mean, those drivers still do that. But at the low level now, we can use NMOS to find, okay, what IP address is that server transmitting its signal on? So I don't have to add that to the server driver because I can use NMOS. So we've used NMOS to integrate lots of stuff. I mean, the Sony switchers, Sony cameras, intercom stuff. Thankfully, most of the audio equipment now in the world speaks NMOS because there's a lot of different audio products. I say that because we don't make any audio-specific things. We use them from people like TELUS Alliance. It's really handy that NMOS, which comes out of the Advanced Media Workflow Association, AMWA, there's your alphabet soup. AMWA, we've had NMOS Plugfest events where we test that people's NMOS works with each other. But our experience is that, as an industry, we've turned a corner now where, like with 2110, with NMOS now, when we integrate with some new thing in a customer project, we generally expect it to work and then deal with exceptions when there's something to engineer or to think about. But it's become routine that NMOS can plug together and can work. And we are really encouraged by that because NMOS is kind of a new solution for a new problem, which before you could get by with just feeding a device a signal and you don't worry about it. With IP, the broadcast controller needs to have a little bit of interaction with the destinations to tell them both, what IP address should you listen to? And in 2110 video, there's some metadata that comes with the video. Things like, are we doing HDR? What is this 1920 1080 or is this 1280 by 720? You have to know this stuff to receive the signal correctly. And that all comes to the destination through NMOS. So NMOS is in parallel with the development of 2110, there was a equal amount of standards work that went on through AMWA to develop NMOS. And since they proceeded in parallel, they got done together, as opposed to, if we did one and then the other, it would have been much worse. So that's part of why it's good to have so many standards groups, is so they can work on things in parallel.
So as a kind of a bystander, I mean, as a broadcast engineer, but mostly in the audio world, when I do occasionally dip into the world of video, I do hear these other standards like NDI and CDI is one that I just recently heard of. Is there a way that engineers might think about the right place for these various different standards, or is really 2110 kind of like the one ring to rule them all? Tell me about that.
Well, the marketplace moves in its own ways. So SMPTE 2110 and NMOS are designed by many people in a public process to achieve a certain result. And in parallel, there are vendors or groups of vendors who do things that are sort of more private and less open. And so Dante in the audio world is one where there's a set of products that do Dante, and there's products that do AES 67, and you can, in very limited circumstances, interoperate them. And ask somebody from the audio world about that. But I'm told that it can work. Then, likewise, in the video world, there were, at the beginning of the 2110 process, a number of proprietary things going on. So Evertz had their Aspen system, Sony had their NMI system. There were others in various stages of development that didn't come to market. And then we all said, look, let's, through a trade organization, the Alliance for IP Media Solutions, we got together and said, look, let's, for the good of the industry and for the good of all of us, let's have one roadmap that we all kind of get on. But that said, NDI in particular came along sort of from a little bit different space, from New Tech and TriCaster and all that, and it has achieved a significant following. There is a reasonable amount of NDI equipment in the world, more every day. It works for its purposes, and at this point, much like with Dante, where the discussion is really about how do you interoperate a Dante island with a 2110 network or an AES67 network, we talk about how do we interoperate a NDI environment that might exist for news and for some other parts of the station where it's really, where it makes sense, to a 2110 environment maybe in the playout side of the house. And you will see more and more discussion of how do you interoperate the systems from a routing control level, from a signal level. They are, NDI is designed and built fit for a purpose, and it's implementing that purpose to many people's satisfaction. 2110 was built fit for a purpose, and it's implementing that purpose to many people's satisfaction. And so they both, exist in the wild, and will be, the interop of them involves turning one into the other, just like it always has.
Gotcha. Yeah. And as you mentioned, 2110 is very much a public out there standard that people, is there a cost to manufacturers other than designing and building toward the standard? Do they have to pay anybody to use 2110?
No, 2110 is the result of a free and open public process. In fact, SMPTE has made for a while during COVID, and I don't know if this is still true, but SMPTE made the 2110 documents themselves free to everybody. And I suspect a little bit of web searching will turn them up for anybody who really looks. But there's no, that to my knowledge, there's no 2110 magic patent pool that if you don't pay $5 into this pool, someone's going to come looking you down in the alley. So it is, you can make 2110 equipment, and please do. There's no, to my knowledge, licensing entity or magic patent that you have to go license. That's the nature of the process. Is SMPTE by definition is an open public process. Now you have to join to participate in that process, but there's not, that's true of IEEE and every other one of the open public standards processes.
Right. AES video. Yeah.
Yeah,
So
AES.
when you're speaking with customers, with broadcasters or video production people, and they're really thinking about 2110 here, and they want to find out, or they really start getting into it, getting the questions answered. I'm curious to know what typically constitutes their aha moment, like, okay, I get it now, and what comes about as the biggest surprise as they discover what 2110 is about and what its implementation implies for their facility. What's the aha moment, and what like, oh my goodness, I had no idea it worked that way or could do that?
I think early on the aha moment becomes the realization that 2 full racks of router plus all the patch bays around it is going to be empty rack when they're done, and that
Yeah.
it's replaced by these Ethernet switches that are so much smaller. I mean, a 32 port 100 gigabit switch is a 1RU item, and that's 3,200 gigabit ports. Each of those ports will support, for planning purposes, 50-ish video things, and you'd multiply it out, and you're like, wow, that replaced 2 whole racks of stuff plus the patch bays. Now, then they have the equivalent aha moment of, that means they don't have patch bays anymore.
Mm-hmm.
And and patch bays are a nice debugging strategy, but there's others. I think where the patch bay is missed the most is in the patch bay was my last resort of, God forbid, the whole thing failed. I could go patch something into the switcher and patch that over to the master and patch that over to the transmitter, and I could be on the air, and that's true. And so people are actually keeping a little bit of patchability of some critical items. Even when they're an IP, they tend to have an SDI output maybe. You have to think through, what is your redundancy model? And for error redundancy, people, like you do with playout, like you do with master control, you have 2, right? So with the Ethernet switches and with 2110 in general, the whole thing was designed to support true redundancy, that 1RU Ethernet switch, or maybe you buy a bigger one because you need more, have 2. You have an A and a B, red and blue, we call them actually.
Yeah.
And you can wire everything to both, and it covers failures of fibers, failures of optics, all kinds of failures that we frankly never worried about in SDI, because if a cable fails, at least it only takes out one thing. But it's now an IP. You say, well, I got 50, 60 signals in that cable, like video signals, plus all the audio that went with them. Or I'm feeding my entire sound room through this one fiber. Maybe I should have a duplicate of that. It's a different kind of problem. So the design of the IP system brought its own solution to the redundancy thing.
Yeah.
But you do have to think through the failure modes. And that's true. That's been with us always.
A few years ago, it may have been like 13, 14 years ago, we did a big installation of in an audio facility, a nationwide talk show that's hosted here in the Nashville area where I live, literally millions of listeners every week. And the engineer in charge said, no, I got to have patch bays. We've got to, if that thing fails, pointing at some of our gear, or that thing fails, I want a way to do this. Well, he would have needed a whole lot of patches to keep the show going on. But anyway, he wanted to have a patch bay. And for the next 6 weeks, maybe 2 months, every single problem we found was, guess where?
In the patch bay.
It was air gaps in the patch bay. Let's focus on a different kind of redundancy than what you've been used to, because that's where our eggs need to be.
Yeah, when I walk through a facility and they have a giant patch bay like that, and they explain, why do you have that? Oh, that's for redundancy. And I said, where are your patch cords stored? Like, if you really had to patch around the router, do you own more than 50 patch cables? And do you own ones that are long enough to reach from there to there? and some people do. I mean, I'm not saying that people have the wrong answer to that question universally, but it it varied, right? That's the difference between a feel-good solution and a could use it if I had to solution is big.
And I realize that the considerations that go into television over IP are much greater than audio over IP. But to this point, my practice has been buy a second switch, have it configured and programmed, and either balance your use of two switches, or just somebody in the market needs to know how to move every cable from one switch to the other. You'll be off the air for 10 minutes while things come up, and then it'll all work again. And we've tested that, and it works.
Yeah, and like and by the way, like any redundancy strategy, during system commissioning, when you have the luxury to do it, you better try every one of those, maintenance procedures of how do I replace the switch? Okay, who's on second shift? You're going to do it this time, and we're going to go through the process. Because if you don't rehearse those failure modes and what's going to happen when that fails by like going and pulling cords and making it fail that way, if you don't rehearse those, then you'll wind up rehearsing them on air sometime.
Yeah, exactly. What you don't want to do. John, I'm so sorry, but we've come to the end of our hour. It's been an absolute pleasure to chat with you and pick your brain on these issues. Is there any topic that you didn't get to talk about that I didn't ask you about that you feel you need to get out there right now?
I think that the topic we didn't talk about that people can always start doing today and independent of IP is kind of around logging. That every piece of equipment you've bought over the past 10, 12 years generates telemetry and generates log messages that if you don't take them and funnel them into a system, then you'll have a hard time sorting out later what happened. And it's a great way for people to get sort of involved with the IT aspect of their plant, is to try and set up a logger and forward log messages into it and learn about, all the different log protocols. And there's no shortage of free loggers to choose from. You don't have to go like break the bank of the budget to try and find a logging system. I mean, there are expensive ones too, but for getting started, paying attention to the logging and the telemetry that comes out of the things you already own is a great way to find events and to get sort of in touch with the IT side of the, of the plant. Even as the signals are still in SDI or still in AES, you can get in touch with the IT aspects of the management of all that equipment.
Interesting. Good. Thank you for bringing that up. We've been talking to John Mailhot. He's the CTO and Director of Project Management over at Imagine Communications. And you know them. They've gone by a number of different companies all together. And we knew them as Harris Broadcast. 32 years, 7 companies, and 1 desk. John, thank you so much for joining us. Appreciate your time and knowledge very much.
And thank you. Glad to be a part of it.
Chris Scherer, I've enjoyed this last hour. Anything else from you?
Not for me. I did kind of laugh when you mentioned the one ring to rule them all. Was that a reference to his Hobbit Pez collection behind him?
I did see that. I'm sure that brought it to mind.
Sorry, I was kind of preoccupied with the SG base, and I think it's an ES-175, but I'm not certain.
You're correct.
That's my side of the room. Kirk gets the other side of the room, but
Chris,
but that's all I have are the incidental observations of your environment. So I'm the audio guy. I'm just sitting here and kind of stunned by everything you just talked about for the last hour, trying to follow along and play the home game version. So
I'm sure I'll hear from some fellow SBE TV engineers who say, you didn't ask him about blah, blah, blah. I'm sorry. I did the best I could. We should have somebody else do this.
Yep.
All right, Chris, it's time to go.
Well, that's it. Thanks again. This has been the SBE WEBxtra, the SBE chapter of the web. We present this monthly, and we hope you'll join us each time. We'll post the replay on our YouTube channel, usually within a day or so. The SBE WEBxtra is sponsored by Katrine, whom we thank for their support. Katrine, unique experience, individual solutions, reliable performance. If you hold SBE certification, viewing this installment of the SBE WEBxtra qualifies you for 1/2 point in category G, just like attending a local chapter meeting. And that does it for this installment of the SBE WEBxtra from the Society of Broadcast Engineers, the Association for Broadcast and Multimedia Technology Professionals. Thanks to our guest, John Mailhot. On behalf of Kirk Harnack, we will see you next month.